Pythagorean theorem, word problems. When given a word problem, you will have to read and interpret the question. Interpret means like find out what is it that they're asking you for. Okay, comma, then graph the scenario. Right? So some definitions here. A guy wire, right? It is used to support a pole, antenna, etc. So I don't know if you know that when you go on the streets here in Winnipeg, right, you've got the hydro poles here, right? And the wires run through them like this. Have you ever noticed that there's like a wire like this anchored to the ground? Have you ever noticed that they have like a yellow tube around it to prevent you from running into it? So there's the ground here. So this is the guy wire. This is the pole. And this is the ground. And notice that you should see a triangle appear, okay? But a guy wire is used quite often in word problems. So I need you to know what it is, right? It's like trim, right? And the like trim happens quite often. And so you need to know what that is, a guy wire. Base of ladder, for example, right? Where the ladder touches the ground. So if you have a wall, right, and the ladder is leaning against it like this, there's again, the ground is never really talked about, right? But it's there, ground. Oops, sorry, you can't see that, my bad. So there's the wall, the ladder, and the ground, right? This here is the base of ladder, right? Like it's where it touches here. So sometimes it says like the base of the ladder is so and so many meters from the wall. They're talking about this side right here. If they're saying that the ladder is touching, 2 meters up the wall, well, we're talking about this end right here, right? So they give you that measurement. If they talk about the ladder itself, like the length of the ladder, then you're talking about this side right here. So be mindful of that, okay? Compass directions. Right? Driving due south for 5 kilometers, right? Comma, then turning east for 3 kilometers, how far are you from the start? And I'm not going to solve this, I'm just going to graph this. By the way, and you should probably have this on your study sheet, I hope everybody knows their, right, north and south you should know. And it's always the east and west. It's like, which one is it? It's either you or we. What is it? If you put east here and W there, it's you. So you should be like, stay away from that. But if it's we, now we're talking, right? That's what I always tell my students. I know teachers have all kinds of never eat soggy wieners, all of that stuff. I don't know. It's still, but just remember it's we, okay? North, south, I think everybody gets that. But the E and W, where does that go? That's what. So remember that. So if you're driving due south, that's just a way of talking that you're going straight south. So start somewhere on your paper if we were to graph this. You're going 5 kilometers due south, and then you stop. So it's 5 kilometers that you've traveled. Then you turn 3 kilometers east, and notice east is to the right here. So that should be a little shorter, right? That's 3 kilometers, right? So due south, and then you went east, right? And now you can ask the question, how far distance from starting? Okay, so that's basically, you will not always be told, like, put this number here, put that number there, but you have to kind of always see the triangle and kind of interpret and see, like, well, which side could they be asking me for? Well, obviously it's that diagonal in this case, right? Because they give you the other two, right? And so watch out for that. Okay, so I think for now, this is all I'm going to talk about for definitions. And then we're going to start talking about word problems. Like I'm actually going to give you word problems, okay? And I'm going to do that on the back side of this. Okay, so examples. A guy wire is attached 4.2 meters up a flagpole. Comma, then anchored 2.8 meters away from the pole. A. Sketch this scenario. And then B. Determine the length of the guy wire. right? So A, they're telling us that there's a guy wire situation. So you should be thinking, okay, I know what a guy wire is. It's always slanted, right? It's going to be slanted. So the guy wire is attached to a flagpole and it's anchored. I don't know if anchored means anything to you, but anchored is like put down on the ground, right? 2.8 meters away from the pole. So it doesn't matter how you graph it, either going this way or this way. Make sure you have your flagpole like this, right? And there's the ground, right? Don't forget about the ground. So you can decide to have it on this side or on this side. There could be a situation where it's supported from both sides, but it only mentions one here. So I'm going to make my guy wire here, right? And so I know that this height here, it's 4.2 meters. Okay, because we're told that it's attached that high up the pole. It doesn't mean that it's at the top of it, but it is attached that high off the ground. And it's 2.8 meters away anchored. So that guy wire is anchored 2.8 meters away from the base of the pole, or the pole, it just says. So there's your triangle. Okay, so that's what I would be looking for when I ask you to sketch. It doesn't have, you don't have to have a flag there. I don't care. Just a triangle with their sides labeled correctly. So this is my unknown here. So we're going to solve B here on the side. It's the hypotenuse. So it's x is equal to 2.8 squared. So this is going to be, doing the work is going to be the easiest part. It's going to be sketching the scenario where you're going to have a bit of a tougher time. It's 5.05 meters. All right. So Biff wants to walk through a rectangular field comma from one corner to the opposite. From one corner to the opposite corner. Okay. As he is about to start walking, he is being told to walk around, comma, since the farmer does not want people trespassing. The field measures 50 feet by 120 feet. Calculate how much further the trip was. So Biff wants to walk through a rectangular field from one corner to the opposite corner. As he's about to start walking, he's being told to walk around, since the farmer does not want people trespassing. The field measures 50 by 120. Calculate how much further the trip was. Now, there's a couple of things I want to talk about here. So first of all, the field is rectangular, we're told. So you should at least understand that much, right? And we know that is a 50 by 120. So we'll put the shorter side here, the longer side there. So it's 120 on the longer sides and 50 on the shorter sides. So pick a corner. He's over here, and his plan is to cut across the field like this, right? And how much further, and then he's told, no, you can't, you have to walk around, right? How much further was this trip here compared to going straight across? Now, I'm pretty sure most of you are looking at this like, I know that this is the shortest distance, right? I hope you know that, like cutting right across is the shortest distance. But we're gonna have to see how much further, how much more did he walk going across. So first step we need to do is find the hypotenuse. Find distance across. That's the first thing we're gonna do here. So we're gonna call that x. X is gonna be the hypotenuse, so it's 120 squared plus 50 squared. And that is 120 squared plus 50 squared, 16,900. Take the square root of that. That's exactly 130 feet. So we know that this is 130 feet. So you can tell already that, right? This is 120 plus 50, it's 170 going around as opposed to going straight across, which is 130. So we'll go 120 plus 50 is 170 feet walked, right? Minus 130 feet across, and that is 40 feet further by going around. So there you have a rectangle meeting a triangle, okay? Now, I'm going to get you started already today. So I want you to find Algebra and Geometry B worksheet. Okay. Algebra and Geometry. So I know you won't get it all done today. So the one I talked about earlier, as well as this one, that's what we're gonna focus on tomorrow. Okay, so have those ready. The other one, you're gonna have to get it online. But it's the word problems, right? Word problems. So go find this one if you have it. Okay. In your package, if you've already picked up the handouts. If not, I'm gonna make it. Oh, I hung up on them. Rejoin. Sorry. Sorry, folks. I pressed the wrong button. I'm going to make this available to you as well, okay? So if you don't have this handout, I want you to start working on that today, okay? But you'll get some time tomorrow. If you don't have this handout, I will make it available right now. So make sure you get it. Just give me a moment to make it available, okay? And don't hang up just yet. So if you're at home, there's a bunch of handouts here if you come in. But if you don't, it's going to be there right now. I'm posting it.